Here we go, day 3. This one is going to be quick but dense. We are going to look at a little bit more Python syntax stuff. This is going to be about data plotting, which is an extremely important skill to have, not just in this class, but in most of your classes. So let's get to it. Today, we will look at importing data sets. So occasionally in this course, but especially in other courses, thinking about like lab classes, design classes, you are going to have data sets that you're generating externally, things that you measure on equipment, characterization tools, that sort of thing. And then you'll take those data files and you'll need to do something with them. So being able to load those data files into Python is important. And then we'll do an overview of the different types of plots that you have in the matplotlib library. So this will be our main plotting library that we'll use, and there will be some details about customizations. As far as why we do this, well, I mean, it's plotting, right? This is like kind of fundamental to what we do in science and engineering is we have data, we visualize data, and then we share visualizations of the data with other people to say, look at this cool work that I did and look what it means and let me persuade you about the importance and the interpretation of my data and what I think about the results. So broadly speaking, this is a absolutely vital skill set for you to develop. Even within the context of this course, though, later on in the semester, we'll be doing more with solving different types, different categories of equations, especially differential equations, and being able to show the mathematical functions that you're finding. What does this function look like? If it's a function of multiple variables, how can you visualize it in different ways with multi-dimensional plots or with color or other ideas like that? So that is going to be really important. And this will also be something that we can do actually with building into animations. If you have, I'm thinking of a certain problem that we're going to do later this semester where you have this partial differential equation, you have an equation in space, but also in time. And you want to make an animation to show how the system evolves as time is passing based on the spatial effects happening, then that's ultimately what we're building toward with this. But start with one thing at a time. We're going to start with importing data. So text files are one data format that you'll see. For all of these different kinds of files that we want to bring into the Python environment, first you just have to open it. Then after you open it, you have to read in the data to, well, to whatever you're reading it into. Maybe you're outputting it to the console, maybe you're bringing it into a variable, storing it in an array. But first open the file, then read the file. Open works with a bunch of different file types. You can always refer to these slides later if you need a reference, or again, just Google it. So we open the file. This gives Python access to the contents of the file, and then you can read specifically what you want once it has been opened. With CSVs, it's going to be a very similar story. CSV files, you'll see a lot when you're working with experimental data. So in other courses, particularly, um, I'm thinking of equipment work. You're doing characterization. You are getting data from a tensile tester, for example, measuring stress strain data. Then those will often be outputted by those equipment as by those pieces of equipment as CSV files. So to read CSVs, um, they're actually so common that there is specifically a CSV import function within Python. So it really is optimized for working with CSVs. Worth keeping that in mind. Just make your life a little bit better. So first, we are with the syntax with this import CSV business. You can see that we have a reading mode. Surprise, there's also a writing mode. You can write data to CSV. We're not doing that today, but it's a thing. Um, and then using the specialized CSV reader, then you bring in your data. So pandas is another library that is used in Python quite a lot for scientific computing work. And Pandas has its own CSV reader. So that's another option that you have. Um, as far as why you would do this, if you're doing other work with the pandas library already, then just keeping everything consistent, it just saves a little bit of headache, makes things easier to keep track of. And you can bring in Excel files directly also. So if you are doing work in Excel, which to be honest, I do quite a bit. Like I actually use Excel a lot for work and for manipulating data. If I want a super quick plot of something and I already have it as a CSV, open Excel, highlight data, hit graph, get a quick visual on what I'm working with before I get into details. So yeah, these Excel files can be read using the pandas library, and we have this read Excel function right in there. So if you're working between multiple different pieces of software, you have options for what formats you want to use, how to save things, just based on your preferences. Now, with Excel files, because they can have multiple sheets within a single file, because you can sort of lay out your data visually and see where things are arranged in rows and columns, this does give you a little bit more power uh, that you can you can operate with to decide exactly what parts of the file you want to read out. So you can do your organization in Excel visually, see everything that's happening, and then take over to Python and use the read Excel file within Pandas to bring in your data. All of these are options. I don't really have any strong feelings as to whether one is better than the other, but you can try things out and see what works best for you. There is more than one good way to do this kind of stuff. All right, on to the main point for today, which is plotting. You got to get the data in order to be able to plot it, but really producing these visuals is the goal, the purpose of what we're doing here. So these are some of the main types that are in matplotlib. These are not the only ones by any means, but these are the core fundamentals that you're going to use a lot. And as always, you can get into the documentation and see what else is in there if you want to do more interesting or more advanced or just fancier stuff. But realistically speaking, generic plot, scatter plot, bar chart, histogram, and I guess pie charts. That's the majority of what we do for basic data visualization. All right, so for a generic plot, we have this set of commands that you're going to see repeated over and over the next few slides. So we have import our plotting library and our plotting function, and then we create a figure, and then we plot the figure, and then we show the figure. So what's happening in each of these steps? Again, the import defines what plotting tools you're using. Then you have to define your plot as a really sort of as a variable. It is a data structure in Python that you are modifying the attributes of. And then we generate the plot, and then finally you show the plot so that you can see the thing that you've made. I know I just kind of said the same thing twice, but just to reiterate like the steps of the logic of what we're doing. Plots in general in Python are very, very, very customizable. The great thing about doing the vibe coding, like I showed in the last video, is that if you can describe clearly and rigorously in plain English what it is you want the plot to do and to have in terms of its attributes, I want a line thickness that is this much and it has this kind of color gradient, and I want the axis ticks to have this major subdivision and the ticks to be this size. You don't have to have all of the syntax, all of the coding syntax memorized to be able to implement those. If you can just describe exactly what you want to your LLM and then have it generate the plotting code for you. And I actually think this is pretty freeing because it lets you spend your time and effort visualizing what you want the plot to be like and really conceptualizing that image that you want to use to communicate your ideas and communicate your results rather than getting bogged down in remembering all of the different, um, attributes that these plot structures have within Python and remembering the syntax for them. All right. So for scatter plots, we will use these quite a bit in this class if we want to have a y versus x representation of data points. So as we're doing a lot of analysis with functions, then of course we'll have our x-axis, and then you have a set of x values, and then you have the f of x value. And so you have each of these single data points on that function x, f of x, and you can use a scatter plot to represent those. So you're going to see very similar syntax here. Import your plotting tool, define your plot, build the scatter plot, and then show it. For making bar graphs, once again, so this is where it gets really repetitive, but it's good that it's repetitive, right? It's the same basic idea for all of these. There are going to be differences of the syntax depending on the type of the plot, but we import our plotting tool, we define our plot, we make a bar plot, and then finally we show it. Something that is pretty subtle here on the screen, but if you look at the bar chart in the top right, the bars themselves are this sort of navy blue-ish color, and then they do have a slight orange boundary around the outside. So that's what's happening in this edge color equals orange business in the middle. And the reason I point this out is that there are a lot of options that you have for how to improve the visual clarity of your plots, how to make them more friendly for screen versus paper, or how to take into consideration factors like color blindness or other accessibility questions, reducing visual clutter, using contrasting colors to make it easier to read. These are all uh, parts of the problem of creating a good data visualization that are worth thinking about, so that you can have your audience have as good an experience as possible engaging with your data, so that they want to engage with your data. Because if you're putting in all the work to make these things, then hopefully you want someone to look at them. Now, I do say all that genuinely. On the other side, if you're literally just making a plot for yourself, if you're like, I just need to look at my data to kind of make sense of it, then make it however you like it, whatever works for you. Obviously, that's totally fine. All right. And then we have histograms. And you're like, wait, is this a bar chart? So, well, yes and no. It sure is made out of bars, but these are two different kinds of data being represented here. So, a bar chart is usually representing categorical information, and then how much value of a variable is within each of those categories. And this is really showing us how much of each thing. Even when you have a numerical axis like this, what matters is it's, how many at 0, how many at 20, how many at 60, and so on. But this is also, I would argue, more important for qualitative variables. So if we're doing a microstructure analysis, for example, and you want to represent phase fractions visually, then a bar graph might be a great option for that. How much of the matrix phase, how much of, a, I don't know, proeutectic phase, how much of a precipitate phase. And then with each of those qualitative categories, you can have a bar indicating the relative amounts of those different things that are present. Whereas in a histogram, we are showing a distribution of values. So we're saying over some continuous x-axis quantitative variable, what fraction of the data set lives within each range of values for that variable. Um, a classic that shows up in education all the time is grade distributions. If you have a graded assignment and the grades are more or less a continuous variable, like going from 0 to 100, then if you want to know, hey, what fraction of students got between a 90 and 100, what fraction of students got between an 80 and a 90 and so on. That's what you're showing with the histogram. So the idea much more is distributions, probabilities, and importantly, this x-axis should be a continuous or at least pseudo-continuous quantitative variable. So with that out of the way, the syntax once again is like, hey, import matplotlib, define my plot, make a histogram, set the properties of the histogram, show the histogram. Hooray. Now, something that is going to come up more next time, I've just been skimming over it, and I think this is actually the last point to make in this video, is in these last few slides, we've had this subplots thing hiding in plot.subplots, and I haven't really said anything about it. Subplots give us a really powerful toolkit for overlaying multiple plots on each other or having plots inside of other plots. As a very concrete example of where we're going with this immediately is, what if you have a data set, so you have some discrete data points, and you're like, all right, I have a scatter plot of my data points, but then there's a function that I'm going to try to fit to those data points, and I want to know if the points are close to the function. Is it a good fit? Does the model agree with the data? Then you would want to be using subplots for that so that you can make a scatter plot of your data and then overlaid on that same figure have, for example, a line plot of your function so that you can visually compare those things to each other. So that's what this subplots thing is. We'll get more into that next time. I just wanted to plant the seed for now. Finally, we have pie charts. They're pie charts. Wow, look, this looks really similar to the other stuff. Import. Now, with the color map here, this is another option that we have where we are defining the sort of gradient space of different colors that are going to be used on the pie chart. And they don't all have to be blues, or they don't have to be any single shade. You can do rainbow, you can do grayscale, you can do, whatever you want. And then we define our plot, and then we assign it the attributes of a pie chart, and then we show it, and here's our pie chart. Okay, I love pie in the real world. I'm kind of a hater when it comes to pie charts. I'm aware that they have their place. It's very rarely my go-to. It's kind of not my favorite thing. But don't let that stop you. There are good uses for pie charts, and if the moment is right, then you go right ahead and make a pie chart for showing your data. All right, that's everything I needed to say. I'm going to get out of here, and then in the next one, we will be looking at that case that I just brought up of saying, hey, let's have multiple figures. Let's stack plots on top of each other. Let's do visual comparisons, and let's look at model fitting and curve fitting and all that good stuff. So that's where we're going. I will see you there soon.